is systems of linear inequalities. Talking south, folks.
You write exactly what you write.
I would. Make that small up in the corner. Systems of linear inequalities.
Really?
All right. So we have found solutions to systems of equations over the last few days, and the solution was the intersection of the points. Well, today we're going to deal with some inequalities. So I would like you to start, flip your paper over, and write these two inequalities on the back of your paper. We have y is greater than 2x minus 7, and y is less than or equal to negative 3x minus 4. Put those on the back of your paper. And we need to remind ourselves about rules of solving inequalities. In two variables. All right. So what does a solution to an inequality in two variables look like? When we have an inequality and I ask you to solve it, what's the solution look like? It's one inequality, so we have y is greater than 2x minus 7. So there is a line involved, but your answer is not the line. It's the part you shade. Okay? So let's remind ourselves, if we have less than or greater than, what kind of line do we have? Dashed or solid? Dashed, because it does not include the point on the line. If it is less than or equal to, or greater than or equal to, then it is a solid line. And to graph them, it's just like graphing an equation, so probably the easiest way is to put it in y equals mx plus b form. But it won't be equals, it will be less than, greater than, less than or equal to, or greater than or equal to. All right, so if we were to, and I don't want you to do this on a graph paper yet, this is just your notes section. If we were to solve just this one linear inequality, here is my grid. How do I graph this? Go down 7. 1 quietly. 3, 4, 5, 6, 7, and I put a point there. Up to yes, and up to and to the right one or left one? To the right one, so we get a rising to the right slope. So we get a line through there. And draw that line completely through your grid, because we're going to get a region for our solution. We're not on the graph side yet. Not yet, we're still on the back. All right, should this line be dashed or solid? It should be dashed, so let me change it to that. There we go. It is a line, so it should have arrowheads on the end. All right. And now, so this is the day I was asked that you guys have notes. I provided notes to you in the video. Quiet, please. So the shading now, we're either going to shade above or below, and it looks like y is greater than would imply that we would shade above, but what did I do to make sure I shade the right section? Yep, plug in a test point, and if 0, 0 is not on your line, then that's the best test point. So plugging in 0, 0 into the inequality, which means I get 0 is greater than 2x, 2 times 0 minus 7. is 0 greater than negative 7. Is that true or false? It is true. 0 is greater than negative 7. This is a true statement. So I always say you shade the side that is true. So if 0, 0 caused a true point, then we are going to shade this side above. If I do that over here. Color shade, I need to get the color. Up here. Thank you. All right, so there is my solution region. That means I can take any point in this region and it would work in that inequality. Okay? But what happens when we have two inequalities? Two lines, two regions of shading, and your solution to the system of inequalities is where the shading overlaps. Okay, so make those notes on the back of your graph paper.
It's like the national treasure I want.
It is. Okay. All right. System solution. Let's stay focused. You will graph all inequalities. And the overlapping shading region is your solution region. Okay, so that's the key with systems of inequalities. We don't get a number for our answer. We get a graphical representation of a region where any point in that region will be a solution to the system. Okay? All right. Now, these two inequalities that I had you write down, flip your graph paper back over. And now I would like you to graph each of these correctly and shade appropriately with a test point. I want you to test the point. I need to see the work for the test point somewhere on the page. And then shade, and then come up and show me, or call me over and show me your feasible reason. Okay? All right, so we have our graphed linear inequality, and we have our reminders about how to do that, dashed in solid, and we put it in y equals mx plus b in that form, and then we use a test point that is not on the line, and 0, 0 is always a nice test point, and you plug in 0 and 0 into the inequality and test to see if the statement comes out to be true or false, and then you shade the true side. One other reminder I will give you is that when you are solving for y in an inequality, remember if you multiply or divide by a negative, you need to flip the inequality. All right, so now if we go back and look at the system of inequalities that we are solving, we have y is greater than 2x minus 7. So that is the blue line. Oh, sorry, no, that is the dashed black line. We go down to negative 7, put our y-intercept, and go up 2 and over 1. We draw in the line, and it is dashed because the inequality does not have an equal sign. And then we test a point. That's the red writing over here. 0, 0 is not on the line, so I can test that point. I plug in 0 is greater than negative 7, so I shade the side that has 0, 0. I think it's a good idea to graph and shade for one inequality before you graph and shade for the other. So these black lines are my shading on the dashed line. Then I also need to graph negative 3x minus 4. Y is less than or equal to negative 3x minus 4. So I go down 4. I go up 3 and over 1 to make my slope. Notice that is a negative slope. The graph of the line is solid because there is an equal sign. And then I need to test a point. 0, 0 is not on the line, so I am going to use that point, and that's the blue writing that I have here. And I plug into y is less than or equal to negative 3x minus 4. And we get 0 is less than or equal to negative 4, which is a false statement. So if 0, 0 causes a false statement, then for the line that we are working with, we shade the side that does not include 0, 0. So here's my 0, 0. We're dealing with this blue line where 0, 0 is false, so we shade the opposite side. Now the solution to the entire system of inequalities is where the shading overlaps. So I've gone over the overlapping region with yellow, and this yellow region is the solution region for the system of inequalities, which means that I can pick any point in that region and plug it into my system, and it will work in both of the inequalities.